work, power and energy. What is work? How to define the work? Work, it is defined as the product of force and displacement. Another definition for work is, let us suppose it is an object. Applied force on object is F. Initial position of the body is at A. Position of the body is A. By external force, it displaces from A to B. See, by applying the external force, object displaces in the direction of the applied force, then we can say work done. Or work done also defined as the product of force and displacement. Product of force and displacement is called what we call work. Work W is equal to F bar S bar cos theta. This is the formula for work. Work formula is W is equal to F bar S bar cos theta. Here, this product is called scalar product, vector products or products of vectors. There are two types. One is scalar product. Another one is vector product. It is also called dot product. It is called cross product. Right. See, there are the two vectors. Both are vectors, but their product gives the different physical quantities. One is scalar quantity, another one is vector quantity. So here, let us suppose A bar dot B bar is equal to A B cos theta. A bar cross B bar, A bar dot B bar is equal to A bar B bar cos theta. Here, dot, it gives the scalar quantity. So A bar dot B bar is equal to what you say? Yes, scalar quantity. It gives the scalar quantity. Right? In case A bar cross B bar, which is equal to A bar B bar sin theta, which is equal to C bar. See, this product gives the vector. So that is why this product is called cross product or vector product. The product which gives the vector, that is called vector product. The product which gives the scalar, that is called scalar product. Simple. The product which gives the scalar quantity, that product is called scalar product. The product of two vectors gives vector quantity, that kind of product is called vector products. These are two types of products. So right now, here F bar S bar are the vectors, but W is the scalar quantity. That is the difference in between scalar product and vector product. How to write the units for this physical quantity? Let us see. We know work W is equal to F bar S bar cos theta. Here, this is the formula, work formula. CGS unit. Force CGS unit is dyne. Displacement unit centimeter. Cos theta is the trigonometric ratio. So no units for following. Yes. Which have no units? Trigonometric ratios. Second one, logarithms, fractions, ratios, sum of the ratios, sum of the physical quantities, physical constants also, digits, numbers. These have no units, right? So dyne centimeter, which is equal to erg. SI unit, force unit, Newton, displacement, meter, Newton meter is equal to joule. Joule unit taken on his honor of James Prescott Joule. James Prescott Joule, scientist, experimentally explained or experimentally verified law of conservation of energy. Law of conservation of energy experimentally verified by James Prescott Joule. So on his honor, work, energy expressed in joules. Right. Right. What is the relation between joule and erg? 1 joule is equal to 10 power 7 erg. It implies to 1 erg is equal to 10 to the power of minus 7 joules. 1 erg is equal to 10 to the power of minus 7 joules, or 1 joule is equal to 10 to the power of 7 ergs. This is the relation between joule and erg. Right. Here. Work done will becomes 0 in the following cases. In which cases work done will becomes 0? Case 1. Applied force on an object is 0, work done also 0. Case 2. If applied force is 0, work 0. Even though apply the force, displacement is 0, in this also work done 0. See, let us suppose this is an object. Position of the object is A. Now we apply the force. Actually we apply the force, but however it doesn't displaces. Displacement of the body is 0. Due to the 0 displacement, work will become 0. Case 3. Making angle in between the force and displacement is 90 degrees. If theta is equal to 90 degrees, work W is equal to formula F S cos theta, which is equal to, here theta is equal to 90 degrees, which means F bar S bar cos 90. Cos 90 value 0. 0 into something 0. So therefore work done is equal to 0. In which cases work done will become 0? Applied force is 0. Displacement is 0. Work done 0. If work done is equal to 0, what is the making angle between force and displacement? That is the previous examination question. So if work done is 0, in which case work done will become 0? Making angle between force and displacement must be 90 degrees. See, for example, this is the displacement of the body. This is the applied force. So what is the making angle between these two? 90 degrees. So theta is equal to 90 degrees. That is why here work done 0. Right. Work done should be max, in which case work done will be maximum. See, it is an object. Mass of an object is m. Position of the body is A. Applied force on an object is F bar. It is from left to right. Displacement of the body also from left to right. So now both are in same direction. One is one direction, another one also in the same direction. So that is why making angle in between force and displacement is 90 degrees. When theta is equal to 0 degrees, making angle both are coincide with each other, making angle between them is 0. If it is, it makes or it is away from the first one, it makes certain angle. Now both are coincide, so that is why theta is equal to 0. Therefore W is equal to F bar S bar cos theta is nothing but cos 0 is equal to F bar S bar cos 0 1 is equal to F bar S bar. Therefore work done is equal to F bar cross S bar. Work done W is equal to F bar cross S bar or F bar S bar. This is the formula. Right? In this case, which case work done maximum? Theta is equal to 0, which means the direction of the applied force, displacement of the body, both are in same direction, work done maximum. So here theta is equal to how much? 0 degrees. In this case, theta is equal to 90 degrees. Let us see. Theta, work done will be, is it possible to negative? Can work done be negative? Yes. Possibility is there. For example, now we apply the force left to right. Applied force is left to right, but displacement of the body is from right to left. Now making angle between these two is theta. Theta is equal to 180 degrees. Theta is equal to making angle between force and displacement how much? 180 degrees. Therefore, work done is equal to F bar S bar cos theta. Cos theta is nothing but cos 180 is equal to F bar S bar cos 180 is nothing but minus 1. So which is equal to, why? Because 180 is in second coordinate. This is first coordinate, this is second coordinate. In second coordinate, all silver teacups, sine and cosecant are only positive, except these two remaining all are negative. So that is why cos is negative, which is equal to minus F bar S bar, that is work done. Therefore, work done should be negative. See, force and displacement both are in same direction. Here theta is equal to 0, work done is max. Right? This is case 1. Case 2. Force is this one, displacement is this one, or force is upward direction. Displacement is right side. So here making angle theta is equal to 90 degrees. Here work done is 0. Displacement is this one. Force is acting on an object in left side. So now making angle between these two is 180 degrees. Theta is 180. Work done is negative. Is it clear? Like this examiners asking the question. These are the few words about work. Next, power. But see, if a body gets displaced when a force acts on it, work is said to be done. Work is measured by the product of force and displacement of the body along the direction of force. If a body gets displaced by S, when force F acts on it, then the work W is equal to Fs cos theta, where theta is the angle between force and displacement. If both force and displacement are in the same direction, W is equal to Fs. In this case, work done will be maximum. If force and displacement are perpendicular to each other, work done will be 0. In case of uniform circular motion, work done by the centripetal force is 0 because displacement is 0. Work is a which quantity? Scalar quantity. Its unit joule. Positive work. If the angle between force and displacement is 0 degrees to 90 degrees, then work done will be positive. When a load is lifted, then the lifting force and displacement act in the same direction. So work done by the lifting force is positive. Negative work. If the angle between force and displacement lies 90 to 270, so in this case it will be negative. Zero work. When S is 0, no work is done. If F is 0, no work is done. If the force is 0. When theta is equal to 90 degrees, force and displacement are in perpendicular direction, or angle between direction of force and displacement is 90, work done 0. Coolie carrying a load on his head, 0. Next physical quantity is work. Work. How to define the, after work we have another physical quantity, that is power. What is power? Let us see. The rate of doing work is called as power. The rate of doing work is called as power. Power P is equal to work by time. Here, as for the relation among these three physical quantities, if work is constant, relation between power and time is inversely proportional, which means if time period is more to finish the work, that machine or power of the person is less. Power has the less power. Machine has the less power. If time period is increased, power of the machine will be decreases. In case if the machine takes less time, it will takes its power is more power acts. Next, in case if time period is constant, what is the relation in between power and work? Power P directly proportional to work. If work is increased, power also increases. If work is increased, power also increases. There are the two cases, case 1 and case 2. When case 1 is work is constant, case 2 is T is constant. In these two cases, the relation between power and work, these are directly proportional. It is in reverse, inversely proportional. What is the unit to express the power? Let us see. Power P is equal to formula work by time. Power unit watt, work unit joule, time unit second. So right now, see, examiners will ask the question like this. What is the unit to express the power? What is the unit to express the power? Question consists the answer. What is our answer? This is the question. Our answer also consists same. What? Here this is question. This is what? Answer. Everything is same. What is the unit for? What is the unit to express the power? What is the unit to express the power? What is the unit to express the power? Or what is the unit for power? What is the unit for power? What is the unit for power, for the power? What is the unit for the power? Like this, examiners asking the question, please concentrate. Either to express or unit for the power. Both two types. There are two ways to frame the question. Please and concentrate. Right. from the formula work by time, work unit joule, time unit second. So watt is equal to joule per second, or joule is equal to, we have the unit, that is watt second. 1 joule is equal to watt second. This is the unit relation between joule and watt second. Here, watt unit, it's taken on his honor of James Watt. James Watt scientist, on the honor of James Watt scientist. Power expressed in watts. He was invented steam engine. Steam engine invented by James Watt. So on his honor, power expressed in watts. Watt is equal to joule by second, joule is equal to watt second. This is the information regarding this. Why should we take the watt? Because of honor of James Watt. Steam engine invented by James Watt scientist. Another unit to express the power is HP. HP means horsepower. One horsepower is equal to 746 watt. 1 HP is equal to 746 watt. Here, what is the small unit to express the power? That is why we use the kilowatt, megawatt, gigawatt, terawatt. Kilowatt is nothing but 10 power 3 watt. Megawatt is nothing but 10 power 6 watt. Gigawatt is nothing but 10 power 9 watt. Terawatt is equal to 10 power 12 watts. Kilo 10 power 3, mega 10 power 6, giga 10 power 9, tera 10 power 12 watts. These are the few words in this area. Examiners also asking the one more question here. Which of the following doesn't a unit to express the power? Which of the following does not a unit to express the power? Which of the following does not a unit to express the power? Option A, watt. Option B, joule per second. Option C, HP. Option D, kilowatt hour. These are all units to express the power. Watt, joule per second, HP. These three used to express the power. But kilowatt hour, it is not a unit to express the power. Kilowatt hour, it is the unit to express the consumption of electrical energy. Consumption of electrical energy expressed in kilowatt hours. 1 kilowatt hour is equal to 1 unit, which is equal to how many megajoules? That is the question. 1 kilowatt hour is equal to 1 unit. 1 unit is equal to how many megajoules? Right, let us see. Kilowatt hour. Here, kilo means 10 power 3. Watt, same. Hour is nothing but 60 minutes, which is equal to 10 power 3 watt into 60. 1 minute is equal to 60 seconds, which is equal to 10 power 3, 1, 2, 10 power 3, 10 power 5, 6, 6, 36 watt second. is equal to 36 into 10 power 5 into 10 by 10 watt second is nothing but joule is equal to 36 into 10 power 5 plus 1 10 power 6 bases equal exponents must be added. By extra we have the 10 into joule which is equal to 36 by 10 3.6 10 power 6 is equal to mega joule. Therefore 1 kilowatt hour is equal to 3.6 megajoules. Important one. How many units? Only one unit. How many megajoules? 3.6 megajoules. Like this, examiners asking the question from this area, please concentrate. Power. The rate of doing work is called power. If an agent does W work in time T, then power of agent is equal to work done by time. Power is equal to work by time. SI unit of power is watt. It is named as a respect to the scientist James Watt. Watt is equal to power unit is watt, work unit joule, time unit is second. 1 kilowatt is equal to 10 power 3. Mega is equal to 10 power 6 watt. 1 horsepower is also practical unit for power. 1 HP is equal to 746 watt. 1 watt second is equal to 1 joule. 1 kilowatt hour is equal to 3.6 into 10 power 6 megajoule. Watt, kilowatt, megawatt, HP are the units of power. Watt hour, kilowatt hour, units of work and energy.